to write a post about CPython. And I think I'm gonna stay for 1 hour. If I can't do it in 1 hour, I'm probably gonna do it, finish off stream. So I think I'm just gonna start the timer. I'm gonna read the other posts that I did with text-to-speech because I think that I made some mistakes on the other ones. So I'm gonna correct them before. Yeah, and I'm not really sure what I'm gonna write. I think I'm just gonna write some of the stuff that I learned so far. And I'm gonna try to keep it as concise as possible. So pretty much just write the stuff that I think is important. So let me see. I'll copy this one. Forgot what day is it? I'm just gonna put the random day for now. No, whatever. Maybe it's 11 or 12.
The paradox of search. What is the market economy and why does it work? The market economy is an abstraction created based on the pattern of reproduction. So it just works as a computation that creates technology to shape the environment in relationship to whatever the mechanism of reproduction for humans is. So the network of human beings, collective consciousness, computes in real time what is going to be necessary to shape a certain environment based on whatever the fundamental parts of human nature were necessary to survive in the past. The limbic system is the most fundamental part of the brain that creates these desires, which are more commonly known as the Maslow hierarchy of needs. This is the reason that if the market economy is unregulated, it converges towards a Pareto distribution over time. In general, women prefer men in the top of hierarchies because that creates a funnel of information. Genetic distribution is a consequence of mutation that is going to define a geometrical structure of how DNA is related to space-time. The pressure of natural selection defines the funnel I just described, and it is shown in human beings through reproduction. So to simplify, the purpose of the market economy is to compute in real time how does the limbic system of the collective consciousness wants to change the environment so it is more beneficial to it. Money is a database, markets are computation, technology is a consequence of how the limbic system shapes the environment to fulfill it. The main benefit of the market economy is that it's not necessary to know all of the complexity of the environment beforehand. It just computes the technology on real time. This is why it works well to a certain extent and is scalable. Why is the tendency for technology to destroy humans over time? The limbic system overfits the environment. Through the computation of the market economy, the limbic system of the collective consciousness creates technology that shapes the environment. This is a cycle that is directly correlated with the frequency of computation of the market economy. The problem is that the limbic system doesn't adjust itself to the new environment it creates over time at the same rate that it changes the environment. Politics are supposed to be the regulating force that recalibrates the limbic system to work on the new environment created by the market economy. The issue is that the human hardware, the biochemistry of our biology, is not scalable on space-time. In order to maximize energy efficiency, Occam's razor, humans limit themselves to tribes. So when humans scale to numbers that go way beyond a tribe, around 150 people, the natural tendency is for different groups/tribes to be created, and as a result there will be conflict between them. The boundaries between different tribes show one of the core essences of the multifractal geometrical structure of how societies shape themselves in relationship to space-time, cities, states, countries. So how is this related to search engines? Search engines are an extension of how the brain consumes information from space-time. The computation the limbic system does is directly correlated with how it perceives information. The brain filters the complexity of the environment based on what the subconscious body thinks is important, which is a consequence of how that body existed through space-time, because it is directly correlated with gravity. That means that search engines will be a consequence of how this mechanism works on the collective consciousness level. The results of searches will be based on whatever the gravitational force of the network that creates the hierarchies of importance, relative to the current state of space-time, is. This means search engines are a byproduct of how the limbic system of the collective consciousness filters the complexity of the environment and also a direct consequence of the computation of the market economy, which creates the incentives for the results the search engine will show. Computational boundary of search. The way search engines are going to display results is then a consequence of the frequency of computation of the market economy and also of how data of the environment becomes information through computation on a network of nodes, society. Because of the nature of markets, the expansion of knowledge is going to follow a tree data structure. The deeper into the unknown, the more specialized you have to become. Because of this and the fact the limbic system is not consciously aware of the context of the environment in which it exists, the results shown are always going to be biased towards what currently satisfies the needs of the limbic system, which lacks balance with the environment it creates. In simple terms, the search engine becomes gamified through SEO and the production of results is biased because nodes are incentive to only produce content for the masses. Since that's where their
I think that's one is incentive.
there's most money to be gained.
I meant to say incentivized, so I think I confused the two. Incentivized. I don't really care that much about the structure. I just wanna put the post out there, but just gonna fix since I'm gonna write another one. So I'm gonna see if there's other mistakes on the other ones. Then I start the CPython one. I think I'm just gonna talk about terminals and non-terminals and the grammar, which I clarified a little bit. I'm gonna say I wanna make it on a very concise way to say like what are the main important things to know. So everything is an object. Every object has a type and a reference count, and then the types are different, and that's what makes each thing in Python different. So depending on which type it is, they're gonna have certain properties which are related to that type. All the objects are gonna have their methods, and a class is just a different keyword for a type in Python. So they are essentially the same thing. When you create a class, you're creating a custom type. That's what you're doing. And then a meta class allows you to redefine the type you are giving to a class. So if I have a class called John and another class called Annie, I can make the Annie a meta class of John by passing meta class equals Annie as an argument to John. And then if I do that, then the type of the class John is not going to be John, it's going to be Annie. But if I don't do that, then the type is John. So that's the main difference between the two. And then you can modify the behavior of classes with the new method, new dunder method, and the init. And I don't remember really well the nuances behind them. Obviously, the init is going to be the function that gets called every time that you initialize an instance of the class. And the new, I don't remember really well what is exactly the difference, but I know that you can customize. And then the main thing that I learned so far now that is becoming more clear in my mind is that all the grammars, like Noam Chomsky, not really sure if I'm saying correctly his name, what he invented or what he proved is some mathematical thing, I think, that shows the connection between non-terminals and terminals, which are the things that define grammars. So based on a set of rules you create, the grammar can have infinite inputs, but if you create the rules in a certain way, it allows you to structure the syntax of the grammar, and that's what terminals and non-terminals are. So everything eventually has to be boiled down into terminals, but then you can have phases between the terminals, which are the non-terminals, which is just ways to make up rules that are based on combinations of terminals. So it's not complicated at all, actually. And maybe I should draw the analogy, but I'm not really sure if I'm gonna do that because I think I am, but it would be nice to put it on the different category. But the analogy between terminals and non-terminals when it comes to compiler and when it comes to instrumental conversions and AI alignment. I'm not really sure if incentivized is the correct way to put it. How can I search for this? I think I'm just gonna go look at the translator. I'm just gonna leave it like that. Fuck it.
Gained. This generates a vicious cycle where the gravitational force of the network becomes unscalable on space-time. Conclusion. In order to make better search engines, it's necessary to understand the biases of the computation that a network create over space-time, and be aware of how the search mechanism is going to become biased over time because of the paradox of search. You can only search what you already know to a certain extent, so the results a search engine displays are always going to be a consequence of how the geometrical structure of a network of nodes gains information on space-time. What is considered to be true for the network is just a consequence of the gravitational force of how the information was computed by the network in relationship to space-time. If there isn't any mechanism to recalibrate this over time, there will be a high chance that the network will overfit the environment at some point, because there will always be variance on space-time. Entropy, because that is the essence of time and space itself.
Another thing that I learned is that this library here exists, and it does pretty much what I was not what I was trying to do, but it does one variation of the things that I am thinking about doing, which is like it builds a graph from the abstract syntax tree, I think, or something along the lines of the process of compiling the language. So I installed this library locally, and it seems like the code is not that complicated at all, and they are using Vue.js. So what I'm thinking about doing, what I'm probably gonna do is just study this code. I'm not really sure. Probably tomorrow, I think, because I don't feel like studying this now. So like I think I'm upstream. I'm probably gonna like continue to read the other stuff here, and the other stuff is that there is this PyPy, which is another Python compiler that is written in Python, and I just realized that like if I'm gonna do things in Python, then obviously I could search for that as well, and then I think it might be a good idea to also spend a bunch of time studying the PyPy interpreter, because then it's going to be interesting to contrast the two. And I downloaded it here, but I'm not really sure if the code that I got is the one that contains like the actual code for the compiler. I'm hoping that is this one, so I'm probably going to do this tomorrow. I'll go over this code here, studying. So this one, it seems very simple as well, and it is exactly like the thing that I created is a pretty much based on Vue.js, but then I just changed everything so that it works with Three.js. So it's exactly the same thing, and it seems like the code, the actual code that they use to create the Python visualization is not that hard, because Python has embedded into it. Like someone either it was created as like with Python itself, or someone created the library, these libraries here, that are very simple to use, I think. So like all that is doing here is just reading the file and then passing to this compile function, which gets the compiled version of the code, and then uses this library here to get I think it creates the abstract syntax tree, then calls this function, which is gonna translate that into a web server and then creates the template thing. But I can do that with my own code. So all I have to do is just study these libraries here, and then I'm going to be able to build it, I think. And that's probably going to be the approach that I'm going to go with. Just use the high-level libraries. There's also the AST library that allows you to do a bunch of things, create the trees, which I was already using here on some of my code to create the graph that I have so far there. So I'm probably going to use these functions here. I was using this, just asking ChatGPT and using this. But I want to spend more time studying the PyPy and studying CPython to like really understand how it works on the source code. I think maybe now I'm going to write the basic stuff first, then I think I'm going to write, not write, but take pictures of the source code to put on the thing as well. It's kind of annoying because it's more work, but maybe it's worth it. So like maybe I should have something in the beginning that just describes the main fundamental. The main thing that I want to achieve is just like make it very simple and straight to the point, so that it is just like I just cut all of the stuff that doesn't matter, and that's what I'm trying to do. The post. But I think what I'm gonna do is just also translate some of the notes here that it took, and then put like pictures of the source code, and then describe the flow between the things, which is still kind of confusing to me. Like the part that is confusing is that Python uses a parser, I think it is a parser generator. So the way that it works is that once you define the rules of the grammar, which is just syntactic structures by Noam Chomsky, it allows you to, like, people created a program that takes the constraints of the grammar, which are the terminals and non-terminals, and then creates the parser code from that, because the parser code is always going to be like the same thing. It's just going to be a tree structure that represents the terminals and non-terminals, as far as I understand now. So there's this additional tool that is a parser generator that takes in the grammar and transforms into the AST. Either AST or a step just before the AST, and then it becomes the AST. But in the actual Python code, it's very confusing to understand when that happens. And like, based on the stuff that I've seen, it looks like that the Python compiler doesn't take the actual string for the code and transforms that into the AST, that transforms the tokens, transforms the string into tokens, Lexer tokens, and then transforms the tokens into the AST. It looks like it transforms everything into tokens directly based on these generators, but it's kind of confusing. So I need to clarify that more, I think. So, yeah. And before, Python was using this pgen, or however you say this. And then they recently, I think on Python 3.9 or 3.10 or something like that, they changed to this PEG. So as far as I understand now, the older version uses something called context-free grammar. And the context-free grammar, there's like the main difference between the two. I think I'm gonna write this stuff down, but I'm not really sure because I don't understand the nuances very well. But pretty much that when you create non-terminal rules, or when you create terminal rules, there are situations where you can have multiple different options. So it's this notion of a non-deterministic automata and a deterministic finite automata, which is just a graph that represents the flow of logic between different nodes. So if the flow is deterministic, then it is a deterministic finite automata, and if it is not, then it's non-deterministic. And the difference is pretty much that on a deterministic one, you always have like a deterministic option based on the place you are. So you can imagine that you have a non-terminal, which is just a higher level structure of the language that is going to eventually become a terminal. But in the path of the non-terminal becoming a terminal, it can have multiple different options. So on a context-free grammar, it allows you to select different options depending. And this is the stuff that I'm not 100% sure how it works. Like, what is the criteria to select multiple different options at the same time? It's kind of confusing. But on this PAG, which is a parsing expression grammar, it is deterministic, which simplifies the process because it means that Python always takes the first option available. So if a non-terminal can become a terminal, when the non-terminal is going to become a terminal, Python is always going to select the option that fits the criteria the first. Unlike the context-free grammar, which can take multiple different options. So for example, a terminal would be a digit or something like that, and then a non-terminal would be a string that contains letters and digits, for example. So the parser receives the non-terminal, which is the string with the digits and the letters, and then it's going to convert that into the terminal, which is the digit. And then in the way that it converts can be non-deterministic or deterministic. And the non-deterministic is context-free grammar, and deterministic is this one here. Probably there's other variations as well, but yes. So Python, for example, in that situation would always take the digits terminal, for example, if it is the first, but you can have a language that is either going to take the digits or the letters, and then from that is going to create other stuff. So yeah, I'm not sure if that's confusing. The reason why I'm not really sure if I'm going to put that is because of that. I don't understand the details very well. So I think I need to study more to... But maybe you should attempt to write about... I think I'm just going to write the brief overview of what I'm thinking right now. I'm going to read this other two first to see, because I remember, I'm not really sure if there is other mistakes that I did here, but I think I'm going to correct them first, then I will start writing the other one.
Is gender binary or a spectrum? Both answers are always correct. The extreme ends of a spectrum are always correct to some degree because they are codependent. Left can't exist without right and right can't exist without left. This means at one level of relativity gender is a spectrum because it is a consequence of the distributions of hormones inside the body. The gradient of energy that makes up the physical form is infinite, which means that the composition of someone's biochemistry is always going to be on a spectrum that converges towards infinity over time. However, at the same time there is a distinction between man and woman because physical form can't exist without distinction. This will create a relative polarity, which is the relationship between men and women. The interaction of this polarity creates an endless growth of information, which is the essence of space-time. So you can't have man without women, and their physical representation is a polarity, a binary distinction between genders. However, the spectrum of sexuality is infinite by nature. Otherwise, the gradient that connects the relativistic polarity wouldn't exist. So sexuality is a spectrum because it is a consequence of a gradient of distributions of hormones which are going to be determined by the genetic distribution of biochemistry, DNA, of a social structure. But at the same time, by definition, gender is binary because the definition of matter in spacetime is a distinction/polarity, which is the nature of geometry. Conclusion. So both perspectives are correct at the same time. The way someone feels about them is a projection of what their biochemistry is aligned with. Straight people can't exist without transgender or homosexual people because someone's sexual orientation is a byproduct of the spectrum of energy, which is a symmetry by nature, masculine and feminine. Depending on someone's biochemistry composition, they are going to exhibit behaviors that are more masculine or feminine or both depending on the situation. But the physical representation of their energetic balance is going to be a polarity because otherwise the boundary between masculine and feminine wouldn't exist. Geometry by definition is distinction, and distinction is polarity. So the spectrum of sexuality is infinite and always convergent towards a relativistic multifractal symmetry. But at the same time, the physical representation of masculine and feminine is a polarity because that is what defines geometry in spacetime. The fundamental structure of perception. Perception is symmetry. The only way to perceive something is if you have an observer and something being observed, or in other words, a distinction. By definition, this is symmetry. Because the fundamental nature of reality is infinite, it means that the symmetrical structure that the nature of perception creates is always asymmetrical. Because if something is infinite, it means it can't have.
Yeah, this one. Go down infinite. Or whatever the fuck. Yeah, here. Also forgot to... I think I'm gonna delete this one. In the future, maybe I'll do it. Or maybe I'll just write... or whatever.
Have a middle, otherwise it would be finite. That means the structure of spacetime is always a convergence towards a symmetry that doesn't exist. Asymmetrical symmetry. Paradox is the highest approximation of balance under the lens of abstraction/information. Because the essence of spacetime itself is the convergence towards relativistic paradoxes in relationship to the reference frame of an identity that creates the multifractal structure of relativistic symmetries. This is why in any important issue of human consciousness you're going to have two sides of the spectrum, and the entire arguments on both sides is going to be around how to define the line/boundary between the two sides of the polarity. The convergence is infinite. So the discussion highlights the computational frequency of a network of nodes converging towards a relativistic equilibrium, which is the essence of geometry/math/information. Conclusion. In order to reach higher levels of discussion and understanding is necessary to approach things with the meta-awareness of the relativistic polarity that makes up any issue. The challenge with that is that the structure of your survival and reproduction incentivizes you to be biased towards whatever maintains yourself alive. This is the gravitational force that makes up the funnel of information of your identity, which is the convergence of potential into matter. The structure of space-time. Perception is symmetry. Identity is a multifractal converging in symmetry in relationship to the reference frame of an awareness that creates a frequency from which the complex plane, imagination/abstraction, becomes matter through a relativistic funnel of information.
So let's start. Like, the thing is, I don't remember where I took this from. I read so many texts. I don't think it's like... Because the problem is, if I'm gonna reference, then I'm gonna have to reference everything, I think. So I think I'm not gonna do it, because it's just a small part. So what I'm gonna do is just not put word for word, just get the thing here. Python is both a compiled and interpreted language. Some parts are compiled for optimization and others are interpreted. Not going to get into the nuances to this here. The way the compilation process works is by transforming a string what's written in a file into lexer, tokens, or words, and then creating an abstract syntax tree representation of them in order to extract higher meaning sentences. Once the AST is created, then an intermediate representation of the code is created. You can think about this as a generic assembly version of the code. Like this thing here, I'm not really sure. Like, I'm gonna leave like this, but when it comes to Python itself, I think that is... this part's more complicated because it is gonna be related to the virtual machine, I think. But I don't want to talk about the virtual machine because I don't know very well the nuances of it. And also, I don't think I'm gonna talk about the GIL, which is the Global Interpreter Lock, just watching a bunch of videos about. But the way that it works, I think, is pretty much that Python can have multiple different threads, and then you can have parallel code, but it's not like the threads are running at the same time. The GIL stops all the threads from running at the same time. It just allows one thread to run at a time. But there are ways in Python where you can make it so that once one code is just waiting for an input or an outcome, then the GIL can... the thread can communicate with the GIL, and then like through this process it's allowed for other threads to start executing while the other code's not executing. But it's different than them running in parallel, because them running in parallel would be they run at the same time. So it's kind of like that, but it's not as efficient, but it has less risk of them or having, or maybe no risk of them interfering with each other, because when you have two different threads trying to change the same code, you can have race conditions, and then it creates non-deterministic behavior. And I'm not really sure, but I believe that at some point they changed the GIL. I remember vaguely, way before I studied all this stuff, that someone or somewhere on a pip, something they were talking about that they were changing the GIL or something like that. So I think this part is like a lot more nuanced, and that's the reason why I don't want to write a bunch of stuff about it. But I think the concept is kind of easy to understand. Not easy, but I kind of get it now. But I also think I'm not going to talk about the main interpreter state. which is the part in the beginning. So it creates the interpreter state. The interpreter state has threads. Then each thread has a bunch of frames. And the threads are linked through a doubly linked list, I think, with the interpreter and maybe other threads. And there's the image there that is very good to explain, but that image is from real Python, so like I don't want to use that image. But I think that image explains very well. I'm just gonna talk about the main, like the simple things. I think like the way that Python works, the main fundamental things, and then maybe just write where each thing is at each file. Yeah, but the way that it works in most languages, I think, is the fundamental pattern. Is just you have the string that is the input of the file. Then you convert the string into tokens, which are words. And the tokens, I think, are the terminals. So every lexer... No, actually... Oh, maybe it is. I'm not 100% sure. But I think that might be a good way to think about it. But I'm not 100% sure if the token has to be the terminal. But maybe that's how it works. So every token, lexer token, is a terminal of the language, which is the definition, like I said before, on the grammar of what the syntax is going to be. And then from those terminals, the abstract syntax tree is created, which is going to create a tree data structure that is going to represent how do you generate higher order of meaning based on the combination of tokens. So, and I think one of the main fundamental differences between normal languages and programming languages is that normal programming languages are more in the side of the spectrum where it allows more variance and more undeterministic behavior. That's the main difference, I think, between them. So you can imagine that is a gradient where in one end of the extreme you have context-free grammar, which allows unambiguous grammar, like known terminals can branch off into multiple different terminals at the same time. And deterministic grammar is the other end of the spectrum where you can only have one deterministic option for known terminals. So there needs to be a clear path between a known terminal to a terminal. And I think the reason of that this might be this way is because of variance in space-time, probably. Because it's one of those things where it's going to be a gradient. So I think that there probably is a chance to move languages towards the non-deterministic behavior, but it's going to be a spectrum of information that is going to be based on the gradient of P to NP. Because the difference between P to NP is just the density of information, I think. So the boundary of space-time, which is the boundary of space-time is created in my current model of viewing things based on a network of nodes that creates perception of time, which is geometry, and computation. So computation is the symbolic representation of a network of nodes that creates the passage of the illusion of time, because past and future are created simultaneously through the present. So what that means is that the reason why NP is different than P is because that's the definition of the current version of space-time that the electromagnetic field creates, which is the illusion of information, which is the symbolic representation of the current configuration of space-time. Because you can think about mathematics as being a collection of symbols that are connected by logic, which is the connection of space and time. So every equation has embedded into it this notion of space, which are the differences between different geometrical properties, which are symbolic representations, because you can think about geometry as never being like fully precise, because it's always changing. So the passage of time highlights the multifractal structure of the geometry, in space-time. So you can think about time as being like the changing resolution of the geometrical object in space. And then computation, like computation is the reduction of the infinite complexity into something that seems to be finite, which is space. And that's the structure of space-time itself. So the reason why NP is not reducible to P is because that's the definition of the boundary of perception of a network that has a coherent symbolic representation of the present. And I think that this is related to terminals and non-terminals because this is going to determine how, like, the shape of the terminals and the non-terminals to terminals is going to be a gradient that is going to have infinite complexity, and the the points of the limitation of the terminals and their relationship with known terminals is going to highlight the geometrical structure of the symbolic representation of the region of space-time. So the reason why languages, I'm not 100% sure about this because of the details, like I said, but I think that should be the case. It's just normal languages are different because they have higher variance, so there's more degrees of freedom and more flexibility, which makes it harder to reduce into computation because the complexity of the languages is not high enough to gather all the accuracy of the geometrical structure of space-time. But I think that with time, that's what's going to happen more and more. Like the more computational power you have, the closer you get to that resolution increasing, where there is more space for non-deterministic behavior because you can do more computations. I think that those things are related, but I'm not 100% sure. And I think this is the main thing here about this point is that, which was one of the most confusing parts for me to understand, but I think that have a high degree of confidence that this is how it works now, which is that the main point where like it's kind of subjective is the creation of the symbols. So from the physical level of the hardware, you have like physics determines the impulses that are going to create the visualizations, but then the network of human beings projects the symbolic representation that it has into the hardware impulses. So like based on the symbols that we create in our minds, that are the things that we use to coordinate with ourselves, we create standards and then we project that into the hardware, and that becomes the first jump between the binary impulses and programming. And all the programming is just this reduction, which is the projection of a network of nodes of Occam's razor, which is trying to maximize energy efficiency by decreasing the resolution of the complexity of the impulses into a higher order construct, which is abstraction, which is mathematics, I think. So you reduce all the infinite potential into a concept, and then that reduction is going to depend on how closely related you are to different reference frames, because that's the range where you can communicate with them. Because you can imagine that if the version you have in your mind of symbols is so different than the other things you're trying to communicate, then there wouldn't be any communication because you wouldn't exist on the same reality. So the degree to which you can communicate with others is going to be determined with the structure of geometry that you both have. And the essence of space-time is going to be the synchronicity between these reference frames, like how closely related are their reference frames of geometry, which are symbolic representation, which are concepts, which are projected into the impulses that becomes programming languages. And that's the evolution of computation, I think. So it's just Occam's razor over space-time, trying to create more abstract things with time to maximize efficiency on the network. And the main jump, I think, which is probably going to be a multifractal pattern because everything is a multifractal, is going to be from the hardware to these standards of different architectures. So the compiler, all the compilers probably do this, like you take a bunch of impulses, transforms into terminals, then creates the structure of non-terminals to terminals to create the synthesis, which is going to be a 3-data structure. And that's going to highlight how the rule sets you created are going to transform, are going to shape the impulses so that it creates a bunch of instructions that you can use. So you can convert a bunch of complex impulses into lower level, like lower accuracy, but higher level instructions. That's what's happening. So what I'm trying to achieve is like clarifying the connection between the two. So, and this is the main difference that all the programming languages are going to have, I think, is going to be on the gradient between the terminals and non-terminals that they select. So the rules that they select should generate the code. Because that's going to determine the pathway to the... Maybe I should open SkyDraw. because the other picture is gonna, I think, yeah, let me go back to, it's kind of this thing that I'm trying to highlight here. So this pathway to the words, the symbols, is gonna be what determines the programming language. And the shape of the arrows here, which is the geometrical structure of the language, is gonna be the gradient of terminals to non-terminals that they select. So exactly what symbols you select should be terminals, and what are the degrees of variance that you allow non-terminals to become terminals. That's the shape of the geometrical structure of the language. And then all the differences between all the languages are going to be just based on this gradient. And then based on the fundamental architecture as well, which is arbitrary, which is probably like a singularity point or something like that, because it's probably a multifractal boundary, which is the spectrum of NP to P, I think. So from the hardware to the selection of what the instructions are going to be for each architecture. And then obviously there's a bunch of questions around that, because then like that's pretty much what's going to determine, like, it's one of those things of chicken and the egg thing. Like, what comes first, the programming language or the problem that it's trying to solve? So is Python very big for artificial intelligence because it has some fundamental properties that make it more favorable to artificial intelligence, or is it because of the network of human beings? So I think that it's most likely because of the network of human beings, because it generates gravitational force, because people build abstraction. So it's the gravity of the network shapes evolution, because the computation is a exemplification of the relationships between people, I think. But then how do you highlight this difference? That's the challenge. Different computer architectures have different assembly instructions, because assembly instructions don't have any inherent meaning to them based on the laws of physics. They are standards created based on whatever the creators of the interface between the hardware architectures, OS, and users decided the instructions should be. Not sure if that sentence makes sense. So maybe I should search on this one, where I can find the names for each thing. I think I'm gonna have to close all these files again and then go from the beginning because it's very confusing. I'm gonna see if I can find the names again of the... Oh, there's also the garbage collection, which is kind of annoying. But I think garbage collection is just removing the reference to the objects. And then Python does that for you, but then the question is like exactly how. And I think that PyPy is different than CPython, where they handle the garbage collection in a different way. So I think there's two different types. One is cyclic garbage collection, where it just inspects all the connections, and then there's other type, which is just based on whatever operation is happening, it just removes the reference. It's kind of difficult to think. And the thing that handles memory management for Python is the PyArena part, which I remember vaguely finding on the when I was doing this for the last string. So this is the main one, then it goes to this. Well, the other thing that I realized that before I was trying to do, I tried to use GDB to look into the code, but I realized now that I was trying to do it based on the Python executable, and then obviously it's not going to work because the Python executable is Python already, it's not on C. So I kind of got confused there. I think this is the reason why it wasn't working. So I probably can use GDB here to try to step through it, but I didn't like GDB very much when I used. Maybe I can try here briefly. So I need to remember where is the folder. I think it's projects, then CPython. And GDB main.c, but I don't remember CPython. Let's see if this one works. Or break. By main. Oh, it doesn't have symbols, it's the same thing. Yeah, so I don't know. Maybe something else that I need to figure out. Or I need to build this first. Maybe I need to create the executable first. So run, create the makefile. The thing is, I'm not really sure how to. I would have to go back to the instructions again, and then probably call something on the PC build. Yeah, but then it's gonna build the Python executable. So I would have to see how to get the executable from main.c. Or for the function itself. Yeah, but I'm not gonna bother with this stuff, just gonna look manually. But I think if I could, like the executable has to be from C code, I think, if you wanna use GDB. But maybe not, maybe there's another way, I don't remember really well. I remember that there's some tutorials somewhere that they talk about how to use GDB, but I read a bunch of stuff, so I don't remember where was it. So obviously here is going to be a bunch of files related to each object. So I think this is one of the points of confusion I think I had, and it's more clear in my mind now. It's just that it's not that difficult, I think. It's just that each thing that you create in Python is going to be an object, and then the only difference of the objects is going to be, the main difference is going to be the type. And then based on the type, it's going to create different structs that have different attributes on them. And that's the main difference between different things, I think, on Python. And then the difference is going to be on the way that the C code is going to handle different things like memory. So probably, let's say you have an array, there's going to be functions that on C that are going to make the array expand or contract based on whatever happens with the code, I think. But if you have a string, because it's immutable, then it probably allocates a specific size based on the... It's probably using size of, then passing the size of the string, and it's going to be the struct that is the object that has a type string. So, like, what I could do is just look at the objects here. I'm probably going to do that tomorrow or some other day. And the part that is still confusing is like, how does it jump from the beginning, and it creates all the beginning stuff to the point that it creates the lexer, the tokens. Mainly the thing that is most confusing is the grammar. Like, how does it uses the grammar parser generator to go from the grammar to the abstract syntax tree. I think that's the part that I'm struggling the most. And there is a file here, I think, yeah, this one, that is the one responsible for that. There's another one that explains the grammar, I think it's on the grammars folder. But it's pretty much, that's the way that it works. They have a grammar folder that specifies the rules for terminals and non-terminals. Then they have another program, which I think is this one, that gets those rules and transforms that into an abstract syntax tree. I think it's this one, a Python gram. So here, maybe I should, probably tomorrow I'll spend some time reading this. I think I'm just gonna copy everything and put on the text-to-speech thing. So it's easier to read. Let me... This thing that is kind of tricky is like, I want to write the post as simple as possible. Like, yeah. The problem is that I have to assume anyone can read the post, so I don't want to put like stuff that doesn't make sense, but at the same time I just want to, like, I'm writing just so I can have an easy way to like just cut everything that doesn't matter and then put all this stuff, like only the stuff that I think it will make it easier to understand what's going on. But then the hard part is finding the balance here of how much of this thread and the beginning state should I put there. I'm gonna close all of this stuff and I'm gonna go probably one by one again. This is what I'm gonna do. I'm just gonna close everything, then I copy the beginning here, like I follow this stuff here that I have on this one. Just write the beginning, and then once I have that, then I go one by one to get the actual code and put get images and put images there. There's a bunch of stuff about frame objects as well and code objects. So each frame has a bunch of attributes and each code object has a bunch of attributes as well. And then the frames are linked through a linked list, I think. And also the other important part is the sim table. So the sim table is just the thing that connects the names with the symbols they have. And this is mainly used to calculate the scope of each thing. And that happens at the part of the, once it gets to the point where it's going to translate the abstract syntax tree into the control flow graph, then it uses the sim table to resolve the scopes of each thing. So maybe that's another, I think I'm just going to write like the main thing, main process there. Then I'll try to expand. The tokenizer creates the tokens. And that's the part that has been the most difficult for me now, is understanding the jump between the beginning there and how it creates the tokens for everything. But I think I missed some functions where it converts the file into ASCII or UTF-8, which is just the standard for strings, like to map out strings into numbers. So I think those functions I kind of skipped in the last time because I was trying to understand more in the general thing. Maybe when I look again, it's gonna make more sense. So let me go back to this. Or maybe I should... Which one should I do first? Should I talk about the terminals and non-terminals thing, or should I do this? Maybe we'll do... I'll talk briefly about the terminals and non-terminals, then I do this thing here showing the flow. Yeah, so it creates a parse tree, I think. So the grammar, the parser generator creates a parse tree, and then from the parse tree it creates a abstract syntax tree. So yeah, I'm gonna talk about the... The way programming languages are defined is based on something discovered by Noam Chomsky, synthetic structures, which in a very simplified way means that it's possible to create rules that create language by defining something called a terminal, which is basically the syntax of the language. For example, a digit or a number, and non-terminals, which are basically higher abstraction structures that will eventually become terminals. For example, the digits and numbers combined, which eventually will become either a digit or a number. Over time, people realize that regardless of which programming language was being created, the process of going from the rules that define terminals to yeah. Oh, the question is, do I get into the whole thing about the gradients? Because then I think I'm gonna have to expand into another thing. I'm gonna do that. Because why not? I forgot how to do lists. I think if I just do like this. I think this is the language that is used to create the parser generator or something like that. I don't remember very well, but I know that I got this from some of the articles. Once the sim table is created, it is time for CFG. So maybe I'm not gonna talk about the. Maybe I'll briefly talk about the no deterministic machine or automata versus the deterministic. The question is, should I put the Python stuff first and then talk about the stuff? Because so far I haven't talked about the simple thing, which is just a Python. Maybe I'll put that in the beginning. I think I'm gonna put that on the beginning. Trying to think about a name for this. Python, everything is an object. Object has a type and a reference counts. The main difference between Python is the type of each object. A class is just another word for type. So classes define the types, and a class is something that allows you to define a different type for a class. So if you have Oh, you're welcome. Not really sure how to say your nickname. Someone's saying thank you all the thing. The thing is, like, maybe I should say this all the time, but you should take what I say with a grain of salt. Because a lot of this stuff I don't know very well, so I can rely on that. I'm comfortable with being confident about this stuff for my use, because I'm pretty sure that is correct, but I don't have 100% certainty that it is like this way. So yeah, it's hard to find the balance of, because for me, like, it makes sense and I believe this is correct, but maybe I'm wrong, so Python, everything is an object. The object has a type and a reference count. The main difference between things in Python is the type of each object. A class is just another word for type. So classes define custom types. A meta class is something that allows you to define a different type for a class. John, it will have a type John. It will have type John. When the class should have a different type, you can do this. Now the class John will have type any instead of John. I think for the beginning, I'm just gonna say this stuff here. It's like the main stuff that I wanna resume from, like the things that are important, I think. It's pretty much it. And the rest is just gonna be combinations of the same thing. Yeah, so let me think about the name of this first part. So the main difference between these two is the relationship between the terminals and I think I'm gonna do something on CaliDraw for this. Main difference between these two is the relationship between the terminals and non-terminals for our language. For context-free grammar. Maybe we should just... I'm gonna put CFG only. Because I think by now it's probably clear that which one is which. Now what is the best way I can say this? I'm trying to avoid saying unambiguous and ambiguous because I think it might be a little bit confusing. I just want to make it as simple as possible to explain. The main difference between these two is the relationship between the terminals and non-terminals for our language. Each non-terminal can become a terminal through several different pathways. In CFG, the choice between a terminal will become a terminal is non-deterministic because whenever there are several options problem is kind of annoying to... I think I'm gonna do it on the Scully drop because it's gonna make it a lot easier. So the main difference between these two is the relationship between the terminals and non-terminals for our language. Each non-terminal can become a terminal through several different pathways. CFG, the choice between how the non-terminal will become a terminal is non-deterministic, because whenever there are several different options, it will choose between them. Precise way. I think I'm not gonna do the picture, or whatever. Because the thing is the thing that I talked about, that I have like some confidence that this is correct. I think that the logic that I'm using is correct, but the precise way of the nuances of the how it works is not very clear. And I'm not really sure, like I don't wanna make a mistake on the thing, but I think it is pretty much the relationship between the non-deterministic finite autonoma and the deterministic finite automata. So the PAG is more of deterministic finite automata, because every node on the thing has a unique pathway or unique logic conclusion to go from that node to the other one. So if I have a non-terminal, it's going to become deterministically a terminal to this precise pathway. But the other one is more non-deterministic, because each node can become multiple different options. But I'm not 100% sure on the non-deterministic version how is determined, because if it is non-deterministic, then how does that work? Like, does it create a different structure each time? That wouldn't make any sense, because then the syntax would change, but maybe it does. Yeah, I'm not really sure. Like, when it selects different options, when it can, for different terminals, what happens on that situation? So I guess this is a good question to ask, so I can explore later. I need to see if I can find like examples that would make it a lot more clear of how it works. Maybe I should do the picture of the gradient. It's probably the time that I chose to do this not very good, because it's late here, so, and it's already 1 hour, so I'm gonna stop. Maybe I'll continue this article tomorrow. Yeah, I think that's probably the best thing to do. Yeah, I think I'm gonna stop now, and then tomorrow when I have more time, I continue to write. I think I'm gonna study more this stuff here as well, like clarify this question here. But the thing is that I have a lot more stuff to study, so I'm not really sure. But probably tomorrow I'm gonna continue to write this article, and then I'm gonna start from the place that I left off today, and then from that point, once I finish this article, then I go back to studying all this stuff, and I'm probably gonna spend one more time, like, not sure how long it will take, but like one more time diving deep into the CPython source code, and then probably one more time trying to studying the PyPy source code to understand. And then probably what I'm gonna do after that, maybe I spend 2 more times, like, or just enough, because I really want to understand the jump. I think I need to clarify this. Like, the main thing that I want to clarify is this jump between the file input and exactly at what moment it becomes tokens, and then how exactly is the parser generator used to create the parse tree from those tokens. I think that part is very important, because I think there's something more fundamental here. There's going to be like the same for all the languages, because I think that this is the stuff that is the fundamental part, which is the grammar rules. So the relationship between terminals and non-terminals. And there's going to be a relationship between this and alignment as well, artificial intelligence, alignment, because I think that the gradient between non-terminals and terminals is going to determine the geometrical distribution of the language. And that's how networks evolve, that's how networks create the illusion of time. So time is computation, I think. And computation is the symbolic representation of a network, because that's what creates the illusion of hierarchy, because you have impulses that become geometrical structures. So the space is fixed, and then time changes. So when time changes, it changes the illusion of the boundaries between things, which is the geometrical structure of perception, and that's computation. And I think that the thing that is similar here is that the argument for artificial intelligence on the instrumental convergence, I think, is related to you can think about everything having one goal, but one becomes many and many becomes one, because at some level is the same thing. The difference between them is just a perception, which is an illusion, which is going to be a multifractal. So AIs will have terminal goals, which is the maximizing the objective function that is run through a loss function. And then from that objective function, for example, in large language models, the objective function is to predict the next word. And then Eliezer's argument is that from that objective function, which is the terminal goal, non-terminal goals will arise, which is the power for reasoning and other behaviors that are very difficult to understand. And I think this is the key of the thing. So it's pretty much the same thing as programming languages on the terminals and non-terminals, because depending on the way that you define the terminals, which are the syntax for the rule, where the rules for the syntax of the language is going to create non-terminal things that can be constructed that can potentially have infinite configurations, because the space of input for the language can be it is infinity, because there's an infinite amount of ways that you can arrange the language to create abstract concepts. So it's the same with mathematics. So you can think about, in mathematics, the terminals of mathematics are the symbols from 0 to 9, which are the unique symbols that mathematics has. And then the non-terminals are the mathematical equations, which are configurations of the symbols in ways that create abstract concepts. And that determines the multifractal essence of the language, which is a symbolic representation of a network. And I think that this is related to alignment in instrumental convergence, because the relationship between the two is going to determine the geometrical structure of the artificial intelligence model, which is going to be shaped by the data of the environment, which is the infinite potential. I think to maximize the probability of alignment is probably something related to figuring out how the boundaries of this relationship create multifractal geometrical structures, and how they are shaped through time, through data, and how that data becomes powered through the geometrical structure of the thing. It's going to create computation, which is going to create intelligence, and it's going to shape the environment based on the distribution of power that the multifractal structure creates, which in human beings is going to be tribal thinking, which is not scalable because it's not in alignment with the structure of space-time. So I think that this is important to clarify like this fundamental relationship between how the parser generator works, how the grammar works, the non-terminals, and the difference between CFG and the PEG thing. Then once I understand that, I think I can go back to higher level abstraction, just use Python directly because it's going to be a lot easier, and work on the actual stuff that I'm trying to do, which is just extract patterns from the code. But I'm probably going to continue to do this tomorrow. Just continue to write the article, and then after that, go back to spending much time studying CPython and the PyPy. Maybe try to build something. Yeah. So if I don't come back tomorrow, probably some other day soon.